Hey there, welcome to the Summary Cave. When you hear the word algorithm, you probably think of slick computer code or AI running your favorite apps. But here's the amazing thing. The idea behind algorithms actually goes way back, thousands of years before our modern silicon chips. One historian, Erica Robson, says that in Babylon, over 4,000 years ago, scribes were already coming up with step-by-step recipes to solve everyday problems, like dividing land or figuring out grain yields. These instructions, carved into clay tablets, were basically early algorithms, practical, repeatable steps to get consistent results. Similarly, Timothy Heath, who knows a lot about ancient Greek math, points to Euclid. Around 300 BCE, Euclid came up with what we now call the Euclidean algorithm to find the greatest common divisor. His method is still a big part of math classes today. At the same time, David Burton highlights how Eratosthenes created his sieve to find prime numbers, filtering out multiples in a logical way. These breakthroughs show how repeating logical steps became the foundation for solving problems, but they were still just separate tricks, not a unified theory. Now let's jump to the busy intellectual scene of 9th century Baghdad. Ruggero Rashed and John Armstrong explain how Muhammad ibn Musa al-Khwarizmi pulled together earlier ideas into one big system, which he described in his book on algebra. He wasn't just solving one-off problems, he was creating a methodical way to solve whole classes of equations. That's a real, generalized algorithm. His work had a huge impact, eventually reaching Europe, where his name was changed to al-khwarizmi. That Latin name turned into our word algorithm, so his name is literally tied to the concept. Medieval scholars built on al-Khwarizmi's methods. David Burton says Al-Kindi, around 850 AD, developed algorithms for cracking ciphers using frequency analysis, an early form of cryptography. Later, Fibonacci took these ideas and helped spread the Hindu-Arabic numeral system across Europe, which totally changed math. By the Renaissance, people like Cardano and Ferrari were solving polynomials, and Newton's calculus brought faster, more complex ways to compute, making algorithms even more powerful. In the 19th century, Charles Babbage dreamed up a mechanical, general-purpose computer called the analytical engine. James Essinger says Ada Lovelace's notes on the engine described the first algorithm meant for a machine, a sequence to calculate Bernoulli numbers. She also imagined that such a machine could handle symbols, not just numbers, which was way ahead of her time and hinted at modern computing's creative side. By the mid-20th century, Alan Turing defined the idea of a universal computing machine, showing that algorithms are step-by-step procedures any machine or person can follow. Then Donald Knuth changed programming with The Art of Computer Programming, carefully cataloging how to design and measure the efficiency of algorithms. Enjoying this deep dive? Hit subscribe and join the Summary Cave for more stories about the tech that's shaping our world. After the 1950s, AI started out as hand-coded if-then rules, but those struggled with anything too complex. Stuart Russell and Peter Norvig show how, in the 1980s, machine learning let algorithms learn from data instead of just following fixed rules. In the 2010s, deep learning took off, as Ian Goodfellow and others explain, with neural networks that could recognize things in a much more nuanced way. The big breakthrough came in 2017, when Vaswani and team introduced the transformer architecture. That's what powers the large language models behind AI chatbots like ChatGPT, which are great at understanding context using self-attention. Today, algorithms are everywhere, from recommendations and maps to medical diagnostics. Historian Joel Gouldy warns that as these invisible forces get more powerful, we need to study their impact on society, including things like bias and transparency. From cuneiform clay tablets to AI's silicon brains, algorithms tell the story of humanity's quest for order and problem-solving. Across millennia, each breakthrough, carved in ancient Mesopotamia, scribbled by Greek scholars coded into modern machines, reveals a single unbroken thread: our drive to understand and shape the world. This story, piece by piece, algorithm by algorithm, connects Babylonians' medieval polymaths, visionary engineers, today's AI pioneers. The humble algorithm is more than just code or calculation. It is a testament to our shared curiosity, creativity, determination. As we look back, we see not just the evolution of technology, but the unfolding of humanity's deepest questions and boldest dreams, woven together by the timeless logic of algorithms. To sum it all up, the story of algorithms begins thousands of years ago in ancient Babylon, where scribes created the earliest step-by-step instructions, dividing land, measuring grain. This practical problem-solving passed through cultures, reaching the Greeks, who formalized important methods such as Euclid's algorithm, Eratosthenes' sieve. Fast forward to the 9th century in Baghdad, Muhammad ibn Musa al-Khwarizmi emerges as a pivotal figure. His work not only created algebra, but also brought together these calculation techniques into the first true generalized algorithms. Al-Khwarizmi's name even became the word algorithm, showing his lasting impact. Medieval scholars expanded these ideas. Renaissance improved methods further. Enlightenment improved methods further. In the 19th century, visionary thinker Charles Babbage, visionary thinker Ada Lovelace, they imagined machines that could follow algorithms to calculate and create beyond just arithmetic, from ancient clay to digital circuits. The journey of algorithms is the story of humanity's endless curiosity and innovation. And as we step into the future, every new algorithm we invent builds upon this rich, interconnected legacy, pushing us to solve new challenges and dream even bigger. The 20th century marked a turning point. Algorithms became the very foundation of computer science. Visionaries like Alan Turing reimagined what machines could do, while Donald Knuth laid out the principles that guide how we write and understand algorithms today. Their work transformed abstract ideas into practical tools, powering everything from early computers to the devices we use each day. And now, in the 21st century, machine learning and AI have taken algorithms even further. They've evolved from static instructions to dynamic learning systems, capable of understanding language, recognizing images, making complex decisions. From the chatbots that answer our questions to the recommendation engines that know our tastes, algorithms are woven into the fabric of modern life. But at their core, algorithms are more than just lines of code. They are the embodiment of our ancient drive to bring order to chaos, to solve problems step by step. This timeless thread connects us to the scribes of Babylon, the scholars of Baghdad, and the pioneers of the digital age. As we look ahead, the story of algorithms is still being written, shaped by every discovery, every challenge, and every new idea that dares to dream bigger. All content on the Summary Cave is for informational and educational purposes. Scripts are built on credible, verifiable sources, but knowledge changes as new research emerges. If copyrighted material appears unknowingly, please contact us for a respectful resolution. Our mission is to share knowledge with clarity, accuracy, and integrity. Thank you for joining us on this journey, from ancient clay to our digital future.